Welcome to Deer University, the podcast of the Mississippi State University Deer Lab. I'm Bronson Strickland.
And I'm Steve Demarais. We're both lifelong hunters, deer biologists, professors of wildlife management, and co-directors of the MSU Deer Lab. We explain the latest research, including our own work and that conducted elsewhere.
So if you're interested in deer biology and management, this is your podcast. Every decision you make is a step in your management program, and we give you the knowledge to make every decision count. Hey everyone, just a quick note before we get going here. This podcast is going to have a lot of data that we are going to display. A lot of different graphs, graphics, etc. So this would be something we would encourage you. You may want to watch this one on YouTube. So go to our YouTube channel, MSU Deer Lab TV, and you can see the video that goes with this episode. Another thing is, this is a very complicated analysis. Took a lot of time, and we actually spent a lot of time on this episode talking about the data and how we got these results. But if you just want to fast forward and get to the results, you can fast forward about 1 hour, and that is when we start talking about our findings. And the last thing is that we have, much like with our buck movement publication, we're going to have a publication that goes with this podcast as well. We hope it is ready in about a month, but we wanted to go ahead and get this episode out now. And when the publication is ready, we will let you know on our social media platforms, and there will be a download link, and you can download that publication free of charge. Welcome back to the Deer University podcast. I am very excited today. This is a long time coming. We are revealing the results of our moon analysis, I guess we've called it for short. But essentially, it is, in my opinion, I think it's the most in-depth analysis of the potential effects of how the moon might be influencing deer behavior. And let me qualify right there. When I say deer behavior, we're going to be talking about a study where we use bucks only with GPS collars. And so essentially, this is how might the moon be affecting buck behavior. And Steve, this is something that you and I have been talking about for many years.
Decades, literally. Literally back, we had telemetry GPS collars out in Oklahoma in the 2000s, and we looked for this effect. And we've looked previously with this existing data set and looked for an effect. And this has been, and we've looked at so many other people's attempts using GPS collars to find this effect. And it's been interesting / frustrating / humbling for me personally, because when we get to the survey results, I'm in there. I responded to that survey, and I was with the general trend. And so, yes, and so I will be humbled today by
don't give anything away, Steve. You may be vindicated.
I may be vindicated, but maybe not. Natasha, you've done such an amazing job of really analyzing and again, the same data we looked at. Bronson and I tried looking at this thing, same question a few years ago. And we lack the skill set that you have to really analyze it at the level needed to try to tease these questions out. So you're going to better inform us.
When Steve started looking at this question, he was using a slide rule and maybe an abacus.
Yeah.
I looked at it with something like Microsoft Excel, and now we have a true mathematical ecologist that is able to look at it. And a little sidebar here, too, of note is, Steve, everything we have done in the past was related, and Natasha's going to go into this in far greater detail, but you and I were just looking at moon phase. Mm-hmm. Very simply put, we were just looking at new moon versus full moon. And
Yeah.
every time we described those results, whether it be social media or any place else, we would get input from people that you need to be examining the position of the moon, that it's not just phase, or it may not have anything to do with phase, but it may have everything to do with the position of the moon, meaning
Yep.
is the moon rising, setting, is the moon overhead or underfoot? And again, Natasha will go into great detail there. So what we set out to do here, and I've said this kind of jokingly, but I am about 99% serious here, that we wanted to do something once and for all with the moon. And so credit to Natasha. She has gone into great detail and depth and complication and sophistication answering this question. And so I'm going to pass it over to her, but I also want to acknowledge Luke. Thank you for joining us. And you certainly helped along the way with bouncing ideas back and forth on this issue. You have certainly, I think, have heard from hunters in the past regarding the impact of the moon. And you also helped us with a survey that we distributed to hunters a while back. So, but with that, Natasha, I will pass it along to you. And let me say this too. This podcast, of course, is going to be in our normal locations, audio download, but we are also putting this on YouTube. And Natasha is going to be sharing slides. So there's a very good visual component to this. So we would really invite you, if you're driving along and want to listen to this, fantastic. But we would really like you also to look at this on YouTube so that you can see the results maybe a little bit clearer than just from an audio description. So with that, Natasha, please take it away.
Thank you. Yes, I am going to share some slides because thinking about the moon and the sun and the different positions, it really is a visual thing, which is kind of helpful. So let me share some slides to begin. So really our whole analysis has been based around, are the deer more or less active given positions of the moon and also positions of the sun? So we'll begin by having a look at what that means. What do we mean by position of the moon? I've got a diagram up here that shows us a deer on the horizon of Earth and different positions of the moon around the Earth. And the moon actually cycles the Earth and has different positions in around a 25-hour cycle. So the moon's position, kind of where it might be in the sky, changes every day. So if we think about when the moon might be directly overhead of us, that could be at, say, 10 a.m. And then the next day it might be around 11 a.m. And the next day it'd be around 12 p.m. So every day that shifts by about an hour. So it's not that related to where the sun rises and sets. The moon rises and sets a different hour every day. And that was already a learning curve for me because I didn't really think about that till I started looking at these analyses. And I don't think a lot of people do. So on the screen, I've got a diagram that shows the moon being overhead above a deer and the moon being underfoot directly below that buck, and it rising and setting. So we've got a different time for that every day. And we also, of course, know when the sun is rising and setting at dawn and dusk as well. So all these different positions give us all these different combinations that may or may not be making the deer more active. And we also may look at, as Bronson mentioned earlier, moon phase. So moon phase is how much of the moon we can see shining from the sun. So when it's a full moon, we can see that the sun is directly shining on the moon. And we can see that from the position on Earth as being a full moon or maybe a new moon, which is when it's not shining on the moon at all. So that's the basic. Go on. We had a question then.
Yeah, well, a comment. So Stephen and Luke, check me on this, but my understanding is that from a hunter's perspective, moon phase is all about luminosity. It is just all about the visibility and potentially the carryover effects of greater or lesser luminosity the night before. Moon position, whether it be overhead, underfoot, rising or setting, is all about the gravitational pull of the moon, which I have always challenged, meaning I don't feel the moon pulling on me whatsoever. So I've always wondered, how might that be affecting a deer? But maybe it is. So essentially, we've got two phenomenon there we're working on: the luminosity from the phase and the position and its assumed effects on gravitational pull on deer, which either may stimulate or suppress movement. Is that y'all's understanding as well?
Yeah, and that makes a good point that generally when we look at the data online of moon phase, it can be a percentage. So the moon is 100% full or the moon is 50% full. And generally that comes as a day. So on Tuesday, the moon is full. On Wednesday, the moon is not full. It comes every day. We have a different description of how full the moon is. Of course, it changes throughout the day, but generally that's how the data is. Every day we have what is the phase of the moon for this day? Whereas the position of the moon is the time of day. So it's overhead at 10 a.m. or it's overhead at 11 a.m. So that's different kinds of data because we have the days and we have the times of day as well.
Yeah, and I think I would generally agree with Dr. Strickland, your assessment of hunters and their perception of full versus new moon versus rising and setting, gravitational pull versus luminosity. And we'll get into this in a lot more detail here in a minute when Natasha goes over some of our survey results where we actually surveyed you, our listeners, and asked how you believed the moon is or is not influencing buck movement. But one of the things that I've noticed over, the years of being a hunter and, reading Facebook pages and online forums and talking to other hunters is that there's really no consistent theory out there on how the moon influences buck movement. And so just like one quick example of that, I'd say the one of the most prevailing ideas behind all of this, and people go to varying degrees of, theory on this. Some people have really in-depth specific theories, and some are, just based purely on is it a full moon or not. But one of the most common is that when you have a full moon at nighttime, especially if there's little cloud cover, there's a lot of moonlight that's illuminating the ground, and deer are traveling more at night. Bucks are up on their feet. People believe there's more deer on their trail cameras. They're feeding in food plots more. They're walking by their deer stands more. And then what that translates to the following day is decreased deer activity because bucks were on their feet so much at night. They've filled up their rumen and they're bedded down all day long. I'd say that's one of the most common theories. But on the flip side, I've also heard, 20, 30% of hunters say the exact opposite, that when you have a full moon during daylight hours, bucks are more on their feet. Now, what I don't often hear is, the reason for that. What's the mechanism? Why would deer be on their feet more during day than night? And so we'll get into that more. But, my point with that little rant is that there's really no consistent theory out there among hunters on how or why the moon is influencing buck movement.
Yeah, I agree with that. There is a few different theories in the sense that there's a few different options for you to look at the moon's position and the moon's phase and the combinations and then relate your hunting to them. There's quite a few different options there. But I agree that there's not any kind of mechanism to explain why.
It was also a challenge of we didn't have just one or two hypotheses to test and accept or reject, because there were so many, and Natasha's going to get into this, that there's so many different combinations of when the bucks would move under this condition or that condition. And I'll be honest, it got to be a little bit frustrating because it's like every single day you could find support for one of these hypotheses. And so it was very difficult to rule out a series of days or, 3, 4, 5 days in a row, because one of these hypotheses based on position or phase was going to be, was going to hit for that day. So, and to me, that's part of, I guess, the staying power of a lot of the moon theory is that it's like every day that you hunted where you perceived an effect of, man, the deer are moving today, you could dig up online that, oh, well, today was such and such moon condition. And that's the answer for why today was so good. So
Yeah.
again, that was kind of a challenge going through all these different theories.
Yeah, absolutely. And I think at this point, I'm going to pass over to Luke to talk a little bit about what he knows about what the general hunting community thinks about the position, the phase of the moon, and its influence on deer activity and potential hunting windows. Because we did a survey, or Luke put out a survey on social media, and I'm going to pass over to him to talk about some of the results.
Just as a general introduction to this, before we started this, before Natasha really got into the nitty gritty of this analysis, we wanted to do two main things. We wanted to figure out what hunters thought about the moon and its effect on buck movement for two reasons. One of those reasons is to make sure that we were asking the right questions of the data, to make sure that the questions we were asking would be able to address the most common theories out there that hunters had. And the other reason is so that we had some data to look back on and compare our results with what hunters said. So we put out a survey on Facebook and Instagram, and we had 1,300, 1,400 different respondents. So well over, we had 1,439 responses. And kind of the way we set up the survey was, we asked some very high level questions, 40,000 foot questions. Do you think the moon has an effect on buck movement? And if the answer was no, the survey was over. If the answer was yes, it goes down to the next set of questions, which is, okay, how do you think the moon has an effect? Do you think it affects time spent bedded? Do you think it affects time spent traveling in the afternoon? And then every time one of those questions was answered, it kind of branched off into a subset of more specific questions on that topic, which really allowed us to kind of analyze this strategically. So at the highest level, we saw that 83% of hunters believed that the moon has some sort of effect on deer activity.
Steve, you were part of that 83%.
Yes, I did respond to this survey, and I am in that box.
So when we break that 83% down, now Natasha, correct me if I'm wrong here, but I believe that within that 83%, 25% of respondents believed that only moon phase affected buck activity, but not moon position.
Correct. That's 25% is like a partition of that 83%.
Yep. So then 13% of that 83% believe that only moon position influenced buck activity. And then the remaining 45% believe that some combination of moon phase and moon position influenced buck activity. So I guess the simplest way to sum that up is, of the hunters, which is the majority of hunters believe that the moon has some influence on buck activity. Of the ones that believe that, around 50% of hunters think that there is some combination of moon phase, full, new, somewhere in the middle, and moon position, rising, setting, overhead, underfoot, that influences buck movement.
And I'll pass over to you to talk about exactly why we did we have the results on this next slide.
Okay, so 50% of hunters believe that the moon affects how far a buck would travel per hour. And the reason we framed it this way, per hour, and not just, we didn't ask a question like, do you think the moon affects how far a buck travels? We asked it more specifically and framed it in a per hour context, just because that is what we would actually be testing. When Natasha's analyzing these data, she was analyzing yards traveled per hour for every one of these bucks across the entire hunting season, and that is essentially our response variable. Did the different moon phase or position influence our response variable of yards traveled per hour? So 85% of the hunters that believe the moon influences how far a buck would travel believe that the moon phase and or position would increase the distance or yards traveled per hour by a buck.
Yeah, and at this point, I'll just say that we were looking for ways to describe buck activity. So this is one that we would use, and we wouldn't use yards traveled per day, for example, because the hours in the day change so much from, say, September to December by almost 2 hours. So we looked at yards traveled per hour as a movement rate as one of our ways to describe book activity. And we also used a couple of other ways to describe book activity too in the survey. The next being the amount of time they spent bedded.
Yeah, so 76% of hunters believe that the moon would influence the amount of time that a buck spends bedded. So you can kind of think of this two ways. You can either think of this as the amount of time that a buck spends bedded, or what's the inverse of that? It's the amount of time that a buck spends on his feet. Now, he could just be, standing there, being motionless, watching and listening and smelling, or he could be on his feet traveling to a food plot or chasing a doe or, avoiding a hunter or whatever. Of those hunters, and, for those of you listening that are hearing a lot of percentages, there are going to be a lot of percentages in this survey results section and then throughout the rest of this presentation. So if this is at all overwhelming just to listen to, I would definitely suggest watching this because it'll make it easier to understand on YouTube. So 55% of the hunters that believe the moon affects the amount of time that a buck spends bedded believe that the moon phase and or position will make a buck bed down for less time, meaning he will be on his feet more. So that survey result is complementary to the one that I just went over. Not only do the majority of hunters believe that it's going to make a buck travel more yards per hour, but they believe that he will be bedded for a smaller percentage of time in daylight hours. So those two things go hand in hand.
Yeah, and this provides us with two really good measurements of buck activity. If the bucks are more active, we'd expect them to travel more yards per hour, and if they're more active, we'd expect them to bed down for less time.
Yep.
And this is for daylight hours. And lastly, I'll pass over to Luke.
Yeah, so that's a very important point here. All of the unless we say otherwise, everything that we talk about is going to be in between daylight hours. So legal hunting hours, 30 minutes before sunrise to 30 minutes after sunset. That's how we analyzed all of these data just to make it relevant for hunters. Because some hunters, like I said, have a theory on how a full moon might influence buck movement during the night. But we really tried to frame our questions and the analysis in the context of how this would translate to a hunter and having an opportunity at a buck. So I think this is one of the last survey results we'll go over here, is 81% of hunters believe that the moon affects what time a buck leaves its afternoon bed. And 86% of those hunters believe the moon's phase and or position can make bucks leave their bed earlier in the afternoon. So for the majority of this analysis, Natasha only focused on afternoon beds and when bucks were leaving their afternoon beds or their last afternoon bed. We could have looked at this at the morning bed perspective, but we felt like, with between these three response variables that we really hammered into in this analysis, which were yards traveled per hour, percentage of time the buck spent bedded, and the time that a buck left his last afternoon bed, we felt like among those three, we would be able to pretty well nail down whether or not there was an effect of moon phase and or position on buck movement. And if there was, it would manifest in one of those three ways.
Yeah, and we actually focused more on the first two, at least for these first few results that we'll end up talking about. So buck activity being more yards per hour, less time bedded, and then later on we will talk about the effect on bucks leaving their bed in the afternoon, and also a little bit about them bedding down in the morning too. So to start off, some of that, how we're relating this buck activity to different phases and positions of the moon, we will be using these two descriptions, which is how far the bucks moved per hour, yards per hour, a movement rate, and how much they bedded as a percentage in daylight hours. So we use a percentage rather than minutes, just because we're looking at different windows. For example, when the moon is overhead, what percentage are they bedded? Or throughout a day rated or a full moon day, what percentage are they bedded? Things like that. So for our whole population of bucks that we had collared over the whole hunting season, we can throw out a couple of numbers for yards moved per hour and the bedding percentage. So in daylight hours, over the whole hunting season, averaged over all of our bucks, they move about 265 yards per hour. So this is very dependent on lots of different things, but as a full average over the whole season, 265 yards per hour. And they're bedded down for about 34% of daylight hours as a full average. And these are kind of figures that we can keep in our head when we're talking through this and talking about different positions of the moon, different phases of the moon, and how they might be affecting the buck activity. These are figures we can keep in our head just as being our average, our kind of our baseline. But what's really interesting before we even go into phases of the moon and position of the moon is how much these change over phases of the rut. So if you're watching online, you'll see that I've changed the slide to some graphs. And if you're listening, we'll talk through these graphs. And what these are showing is the yards per hour averaged over our population at different phases of the rut, and also how the percentage they're bedded in different phases of the rut. And the main point is that outside of the rut, so in Mississippi, the pre-rut begins on November 27th, peak rut begins December 25th. And the whole rut kind of period through post-rut ends on February 4th. So outside of the rut, we did have bucks collared from September 1st all the way until February 28th. So outside of the rut was that September 1st until November 27th, and then part of February too. And what we found outside of the rut is that on average, our bucks move 219 yards per hour, and they're bedded down about 38% of daylight hours. But then in peak rut, which is the 2 weeks beginning on December 25th, they actually move about 400 yards per hour and bed down 23% of the time. So you can see that huge change from outside of the rut, around 200 yards per hour to 400 yards per hour, which is a huge amount. And then bedded down outside of the rut 38% of the time, and in peak rut, bedded down about 23% of the time.
So I think that is really important to emphasize here. Sorry, Steve. I'll pass you in just a sec. We really wanted to have this slide in here or talk about these results simply because when we're thinking about hunter perception, and that's including us, perceptions of, quote, the deer are moving or the bucks are moving, we can all relate to the difference between outside of the rut and the peak of the rut. During the peak of the rut, on average, you're going to see a lot more buck movement during that time period. And the difference, so we wanted to use the very units that Natasha is comparing to the moon phase and moon results with the rut. And so what we're seeing here is there is almost double the difference in yards per hour. So we're going from around 200 yards per hour to 400 yards per hour. So that is a really, really big swing in buck activity, and it is tangible and we can see it. So it is a very, very clear signal. So that should give you some idea of the magnitude of difference that's needed to see such a big change in buck activity. And then correspondingly, you just see, again, almost half of the amount of time that bucks are bedded during the day outside of the rut and during the rut. So we just thought those would be good comparison points when we talk about the influence of the moon and comparing it to the influence of the rut. So just something to compare to. Okay, Steve.
Yeah, that's ditto. These are the differences that we as hunters see when we're in the woods. We just expect it because we see it.
Yeah.
It's measurable.
Absolutely, yeah. So this report of results, the changes in yards per hour and bedded percentage through the rut, has two purposes. The first, to show that, I think most of our listeners and watchers have sat in the stands and seen the difference in activity outside of the rut and in peak rut. So everybody watching this can visualize that difference in activity. You've seen what you've seen, and as numbers, we're showing you this difference. It's almost 200 yards per hour difference here in activity, and also way less bedding percentage as well, by about 15%. And the other purpose of us talking about this is to introduce that we accounted for this in our analyses. We accounted for the fact that when we're looking at buck activity, it is way different in different phases of the rut. So when we looked at bucks' usual movements, we looked at the 2-week period for those individual bucks, because of course each buck has a different level of activity anyway, based on its age, based on its behavior. We accounted for those individual bucks having different activity levels anyway, and then also having different activity levels depending on what phase of the hunting season we're in.
Yeah.
So go on, sorry, Luke.
Before we move off this slide, two things. One, if you're listening to this and you took our survey, you've already thought about this question because we asked you about it. But if you didn't take our survey, just think about these numbers we're throwing out here during no rut. So September or way after the rut, bucks are moving about 200 yards per hour, and then at the peak of the rut, 400 yards per hour, and that's averaged across all daylight hours. So that's going to be higher in morning and evening, and then a little bit lower midday, whatever. But just think about what you would expect to see if you're a moon phase / moon position believer. Think about what you'd expect to see in terms of buck movement response. Would you expect half that magnitude, so 100 yards per hour change or 50 yards per hour change? Think about what you'd expect to see. And then the other thing, and this kind of goes back to hunter beliefs and survey results and everything we were talking about earlier. I want to caveat this by saying, or preface this by saying, that there are a lot of moon theorists out there that have spent a lot of time thinking about how the moon influences buck movement. There are plenty of hunters out there who have spent a lot of time thinking it and analyzing it and planning their hunts around it. And, they've done their due diligence, and they don't have just these, theories that you ask them about and they say, well, I don't know, that's a good question. But on the flip side of that, we have all talked to a lot of hunters, especially in the last, 6 months, that when you ask them these types of questions, they kind of sit there and scratch their chin and think, well, I don't know, that is a good question. And to me, that kind of indicates one of these traditional beliefs that the moon influences buck movement, and it's a full moon, so you need to be out hunting. But then when you really get into the details of how the moon does or does not, the ideas of it aren't super well developed. So that's one of the reasons we A, did the survey, B, did this analysis, is to really put some numbers behind essentially every possible theory out there on how the moon influences buck movement.
And one of the problems with our own personal perceptions, and I'm pointing at myself, I have and had perceptions of or beliefs of these things, is, as hunters, we might think we hunt a lot, and maybe our significant other thinks we hunt too much. But in reality, we don't go out and spend 12 hours a day in a stand under all of these different circumstances. We see a minuscule snapshot of deer behavior on any given day, on any given circumstance. And when we tend to target, well, I think there's going to be this effect, and I go out or I don't go out, you're basically reinforcing your belief when you go out, and maybe you see some deer. Or maybe you don't. You think, oh, yeah, that reinforces. We just don't have the database that Natasha had and that we collectively have with this this research project when we rely on our personal observations.
That's a really good point. Thanks, Steve. So on that point, what we're displaying here is our yards per hour, our bedded percentage, our figures for book activity. But these depend on that phase of the rut. They depend on the individual books. So rather than reporting these kinds of numbers for the rest of our results, we're actually reporting changes in usual behavior.
Okay, Natasha, we've talked about our expectations and, movement response, changes in bedding relative to a particular moon condition or not. But we also know that bucks have different personalities, and we know that some bucks are going to move more than other bucks. So how did you control for that, or how did you standardize those measurements so that you could most accurately depict a change in an individual buck and in his behavior relative to the moon?
That's a really good point. So we have a number of bucks in our population, and they all have different kinds of activity levels anyway. And we're looking at averages over the whole population. We can't report the activity for every single buck, or it would be a mess. We wouldn't be able to display, we wouldn't be able to see the patterns in our data. So we do average over the population, but what we do is we look at the change in each of our bucks' usual behavior rather than reporting the kind of figures we see, such as in peak rut, they bed down 23% of the time. So what we look at is the differences in each buck's usual movements within a 2-week period. So the 2-week period accounts for effects of the rut. So activity changes throughout the rut, as we've seen, and just looking at each buck's usual movements accounts for their usual behaviors, depending on that individual buck. And within the 2-week period gives us a window where we're not too worried about the effects of the rut. So because of accounting for those two things, the individual personalities and the rut, we look at the change in bedding percentage and the change in yards per hour, rather than just reporting the average yards per hour or reporting the average bedding percentage, because this allows us to do this accounting for those individual bucks as well. So for example, and we also may look at different windows of time as well, depending on the position of the moon, which we'll get to later. But for example, these are the kind of things we might report. We might report that the change in yards per hour is increased by 150 yards per hour. And if you're watching this online, you'll see that we have an upwards arrow and we have red font for 150 yards per hour increased. So they might be moving 150 yards per hour more. Or their movement rate might have decreased by, say, 100 yards per hour. So we're going to display, if you're watching online, increases and decreases in the movement rate, averaged over our population, but very dependent on those individuals. And we'll also report the change in bedding percentage. So, for example, an increase in the bedding percentage or a decrease in the bedding percentage. For example, on average, bucks might bed 10% more than their usual behavior. And again, when we say usual, we mean for that buck over that 2-week period. So we're accounting for both of those things.
Yeah, I think this cannot be overstated. And I think this is one of the greatest strengths of the way that you did this analysis, Natasha. So, like, if we had just reported how a moon phase and or position influenced a buck's yards per hour for the entire day, average yards per hour traveled for the entire day, we would likely be washing out some effects if there were any, because think about what some of these moon theories predict. They predict that a buck will move more during a major or minor feeding window, which we'll get into more in a second, but those are constrained periods of time throughout the day. So like a minor window is right around sunrise or sunset. A major window is when the moon's overhead or underfoot. So those are only 1 or 2 hour periods of time. So if we look at the average across the entire day, well, that's not representative of the time period that we're talking about. But the way that Natasha did this analysis, if we're analyzing how a minor feeding window influenced movement rates or bedding percentage, the way that she did the analysis, she looked at that exact same time of day, plus or minus a week, and compared it to the change on the day in question. And so I think that's a really, really important caveat here that I want to make sure people understand.
And then furthermore, we really don't care about an instance of a buck. And so when you look at so many different days and the number of animals we looked at, an instance really isn't that important. So Natasha is comparing essentially a particular buck, any deviation that that buck has with his normal movement pattern from the week before and the week after, and whether it's a daily or relative to a period of time, the week before, the week after, at that particular hour.
Yeah.
So just for example, if Natasha was looking at 3 p.m., it is the difference of this buck on a particular day at 3 p.m. relative to all the week before at 3 p.m. and the week after at 3 p.m. And then there's that deviation for that buck. And then she's doing that for every single buck that was collared and then taking the average of that. So that is the average population response for the particular moon phenomenon she's examining. Good point, Luke. We just really want to drill that down, that we thought this was really kind of the next level in looking at how these individual bucks may be responding. And the best way to compare them is to compare them to themselves, how they deviate from their normal movement patterns.
Yep.
Thank you.
And then still generalize using all of the samples. So it's the best of both worlds.
Right.
Yeah, and you were making it sound so simple there, Bronson. But that is like, these are the important things: the individual behavior, the change in the rut, and also later on we'll think about dawn and dusk and the changes then too. So it's just accounting for all of these changes when we look at averages in these analyses. So going back to when Luke posted that social media survey, we actually asked hunters what they thought would be a reasonable increase or decrease in activity for us to really care when we're sat in our stands about these changes in activity. I'll pass over to Luke.
Yeah, so our based on our survey results, hunters believe that a significant, and everything I'm going to talk about here is relative to what hunters believe would be a significant or a meaningful result from the perspective of trying to kill a buck, right? So hunters believe that an increase of 50 yards per hour would be a meaningful change in buck movement rates. And I guess alternatively, if they believe 50 yards per hour increase would be meaningful, they would also believe a 50-yard decrease in movement rates would be meaningful. And then for percentage of time or amount of time spent bedded, hunters believe that bucks bedding for 30 minutes less than normal would indicate increased activity, and they think that that would be a meaningful change in the amount of time that a buck spends bedded.
Yeah, and I just equated that to about 4% of daylight hours. So for a 12-hour day, 4% of daylight hours would be about 30 minutes.
And then last, hunters believe that if a buck left his bed 30 minutes earlier than normal, that would indicate. Now, when I said left his bed, let me clarify that a little bit better. Hunters believe that if a buck left his last afternoon bed, so his last bed prior to sunset, if he left that last afternoon bed 30 minutes prior to when he normally left that bed, that would be a significant and meaningful change.
Thanks. Yeah, so just keeping these numbers in mind when we're talking about how the moon's position, the moon's phase, the sun's position may affect our deer activity. These are what we asked on social media, and these are the results that we got back. More than 50 yards per hour for a movement rate per hour, around 30 minutes difference in bedding percentage. Are these numbers we need to keep in mind when we're looking at these results. So moving on, we'll now talk about what are these solar-lunar theories. What do we see online? What are these data tables? What are these calendars that hunters are generally using to try and find the best times and the best days to hunt based on the moon and the sun? So we'll start off with moon position and something called the solar-lunar theory. Most of the tables that I see online are to do with this solar-lunar theory that looks at the moon position and also the moon phase and devotes different windows of time throughout the day, which may be best to hunt. So starting with the moon position, as we'd already spoken about, the moon can be overhead, underfoot, it can be rising, it can be setting, and this is about a 25-hour cycle. So again, if the moon is overhead at say 1 p.m, the next day it'll be overhead at around 2 p.m, and that changes by about an hour each day.
Yeah, and
Now, go on.
I think this is probably self-explanatory to the vast majority of people, but I guess for those listening who aren't believers in moon phase, or for those listening who just aren't familiar with it, moon overhead essentially means that the moon is above the horizon, so it's visible, and it's equidistant between its rising and setting point. So it is as far overhead as it's going to be. Underfoot is the exact opposite. So the moon is not visible to us, and it's equidistant between where it just set and where it is going to rise. And then rising and setting is just the moon is at one of the horizons, whether coming up or coming down.
Thanks, that's really helpful. So because these have instances of time, when the moon is overhead, for example, the theories are all pretty much consistent that there is a window of time around when the moon is overhead, for example, that may increase or decrease Buck's movement. So we have two kinds of windows that we see in these theories, and I'll explain them. The first being a major window, which is a 2-hour period of time in the day. It sometimes occurs in the daytime, it sometimes occurs at nighttime, which is 2 hours around when the moon is either overhead or underfoot. So when the moon is directly overhead of us or under our feet, and the 2-hour windows surrounding that are called major windows, and we have 2 of those per day. The next kind of window, which again is supposed to be a good time to hunt deer, is a minor window, which are shorter windows. They're just 1 hour long, and they're around the times that the moon is rising or setting. So there's 4 times in a 24-hour period where these solar-lunar theories pretty much agree that these are the best times to hunt and fish, which is the 2-hour windows, major windows, which is to do with when the moon is overhead and underfoot, and the 1-hour windows, which are minor windows, which is to do with when the moon is rising and setting. So these are times of day. These are our windows of time throughout a day, but we can also talk about which days are best to hunt. And some of these solar-lunar theories talk about moon phase. So whether or not the moon is full or new. So for example, when the moon is full, it's 100% full or more than 99% full. And when it's new, it might be more than 99% new. And that's classified as the moon being full or new. And these theories state that the moon being full or new is the best time to hunt. So I might look for the best day to hunt based on the moon phase. Is it full? Is it new? And then I might find the best time of day to hunt based on those minor or major windows. And one of the solar-lunar theories, which I see in a lot of the calendars, denotes these days as being full or new based on some rating. So they say the days are rated 1, 2, 3, or 4, and those are based just on the moon phase. So a day rating of 4 would be best, and that's when the moon is either 99% full or new or more. So it's really, really full or it's really, really new. That's a day rating of 4. A day rating of 3 being when the moon is more than 95% full or more than 95% new. A day rating of 2 being 90% or more full or 90% or more new. And then anything else, the day rating of 1. So days are rated 1, 2, 3, 4 based on moon phase, and day rating of 4 is supposed to be best. So if I was going to look at the calendar for the next week, I might see, are any of the days rated as 4 for this week? And if they are, great, I'm going to choose that day. I'm going to look at minor and major windows that may occur with legal hunting hours, and that's when I'm going to choose to hunt based around these calendars.
So little clarification. So day 2, 90% full. It's 90 to 94.9%. I mean, day 2 is exclusive of day 3. It's not inclusive.
Yes. Yeah. And to me, more than 90% full is practically full, but these are split into different days. Yeah. So a day rating of 4 is a separate thing to a day rating of 2.
And these are not what we came up with. These are published Lunar theory days.
Yeah, so I took these particular ones from a website called solunarforecast.com, but there are many other websites that produce this same calendar, some which shift very slightly, but this is the general pattern, that these major and minor windows are around 2 hours and 1 hour long, and the day ratings are the same as this.
So according to this theory, is that you would use the day rating to pick the day that you wanted to hunt. And notice there is so much weight because a day rating of 2 or 3 or 4 is all relative to 90, 95, or 99% full. Day rating of 1 is everything else. So a tremendous amount of weight on it either being a full moon or a new moon or close to it. So you use the day rating to pick the day, your optimal day, and then you use the minor or major windows to pick the optimal time within that day to hunt.
That's right. And
in theory, that's how it's used.
In theory, yes. And on top of that, the particular place I got these figures from, and many of the other websites, they also say that days rated as 4 when the moon is rising and setting at the same time as the sun is rising and setting, they are even better. So we're not even going into that, but there are increased times when these days could be even better to hunt, to do with dawn and dusk, because we know the deer are moving more at dawn and dusk, and we are going to talk about that later. So we'll talk more later about these when these are even more increased ratings based around dawn and dusk. But for now, that's the basic idea, that days are rated 1, 2, 3, and 4 based on the day, based on the moon phase, and then major and minor windows are based around the moon's position.
Yeah, and getting back to just the inconsistency in theories among hunters, we have heard hunters that believe that, our survey very clearly indicates this. Some hunters believe it should be all about the day rating, right? Is it a day 4 or a day 1? That's what I'm basing my decision on whether or not to be in the woods on. And then there are some that believe it's all about the moon position. So is it rising? Is it setting? Is it overhead? Or is it underfoot? This theory accounts for both of those simultaneously. And the way that Natasha analyzed this, she was able to tease it apart. So she looked at day rating, she looked at position, and then she looked at them in combination.
That's right. And we thought it was worth talking about one more kind of theory, which is similar, but is not always clear that it's similar, and has a following online, which is the red moon theory. The red moon theory doesn't talk about phase, which is how full or new the moon is. The red moon theory talks just about when the moon is overhead or underfoot, so that gravitational pull of the moon. And we have red moon windows, which are approximately 4 hours long. And I say approximately because I've pulled the tables up myself, and sometimes there seems to be a little bit of difference here, and it's not clear why, but approximately 4 hours long, around when the moon is overhead and underfoot. So this is essentially a major window from the lunar theory that is 4 hours long instead of 2 hours long. And also, when this 4 hour long window co-occurs with the sun rising or setting, this is denoted as a red moon day. So a red moon day is when the moon is overhead or underfoot, and within 2 hours either side of that 4 hour window, co-occurs with the sun rising or setting. These moon overhead and underfoot times are the best times to hunt.
So for those listening, just to clarify, our interpretation of red moon, it is independent of moon phase, meaning moon phase has nothing to do with it. But it is a condition where the moon is either overhead or underfoot, and that time occurs while the sun is rising or the sun is setting.
Yeah, so I think I will just recap everything that Natasha just talked about, because there's a lot of different moving parts here, literally and figuratively. So there's two primary theories that Natasha analyzed. There's the solunar theory and there's the red moon theory. The solunar theory combines moon position with moon phase. And the solunar theory is based on the day rating, day 1, 2, 3, or 4. Day 4 being better, day 1 being worse. Within the day 1, 2, 3, or 4 rating, there's also the moon position side of things, major and minor feeding times. So that's solunar theory. The red moon theory is similar but different in that it also accounts for the rising or setting of the sun. So on a red moon day, would occur when the moon is directly overhead or underfoot while the sun is rising or setting. So those are the two primary theories and what differentiates them.
Thanks. That's really helpful. But I will say that we don't explicitly analyze the red moon theory, because what I'm stating here is that this is essentially the same as a major window, but a little bit longer. And this is to do with the increased movement in major windows at dawn and dusk, which is what we analyze. So it's kind of a very similar thing to parts of solunar theory.
Sure.
Yeah, thank you. So moving on, we do have some results here, which is great. And we'll begin just looking at moon phase, not even thinking about moon position, just looking at moon phase, which the lab has looked at before too. But here we're basing this on our individual books and also on that 2-week usual movement for each of our individual books. So I'll start off with just one result so we can understand exactly what's going on here. On days rated as 1, so that's when we pick out all of our movements when days are rated as 1. So the moon isn't full, it's less than 90% full, or it isn't new, it's less than 90% new. We have a change in movement behavior, but it's very, very slight and it's not anything significant. So by averaging over all of our books' movements and their changes in their usual movements, we see that books are moving about 2 yards per hour less. Now, in my opinion, that 2 doesn't really mean anything. It might as well be 0. We have GPS errors on our collars of absolute minimum, probably 10 yards. 10 yards every time we take a location, and we take a location every 15 minutes. So 2 yards per hour decrease, that is measuring error. That it may as well be an increase. Decrease or an increase of 2 yards per hour is not significant to us. And if you remember, an increase or a decrease of 50 yards per hour is what our hunters said would be measurable, would be interesting. And then we look at bedding percentage. We see an increase in bedding on days rated as 1 compared to usual behavior of our books of about 0.4%. Now that's about a minute maybe. So 1% would be 7 minutes. So it's a couple of minutes. So it's not anything interesting. We're taking measurements every 15 minutes. It's not anything interesting. And I'll display now the rest of the results for our days rating of 2, days rating of 3, days rating of 4. And to me, these numbers are very small, whether they're increases or decreases. They're still very small. It may be that the bedding percentage is decreased by 0.2%, which is just over a minute. But the movement rate's also decreased by 0.3 yards per hour, which is essentially 0, which is essentially nothing.
So to put things in perspective on the yards per hour, all you bow hunters will understand this, but when you're pacing off, and we used to pace stuff before we had the laser rangefinders, but my pace is a yard. Every time I take a step is pretty much a yard. So what this is saying is that the greatest effect there is on day rating of 3, 4 yards per hour. So for me, over an entire hour, that would be 4 steps. So 4 steps over a whole hour. So to me, maybe I'm being too much of a skeptic here. I do not see that as a big difference.
Yeah, and these percentages of bedding are so minuscule. They're almost, I mean, if we didn't have very precise data, we wouldn't even be able to come up with these values. And it's nothing that a hunter would be able to visualize and grasp on any given day. You know, that it's a 0.1% chance change in bedding. I mean, you can't see that.
It's
Yeah.
not tangible.
I mean,
You wouldn't notice it.
The most significant, I don't want to say most significant, the bedding value that's furthest from zero that we're looking at here is a 0.7% increase in the amount of time spent bedded. And that's on a day rating 2, not on a day rating 1, which is, I think, what the theory would predict. And that equates to 5 minutes on a 12-hour, during a 12-hour day. That's 5 minutes. So, you know, I kind of the way that, you know, I think we want to / we should display these results for people is we tell them the numbers and they decide whether or not it's significant. If you think that a 5-minute change in bedding is significant, more power to you. I don't think it is, but some people might. And in some, I think you could make an argument in some very, very specific situations where you were hunting really close to bedding and bucks are getting up really close to sunset. You could probably make an argument there. I don't think it's biologically significant for most hunters, but, you know, to each their own.
I think it's a good point here as well that for me to really see a big change based on moon phase or whatever, I'd want to see that in both the movement rate and the bedding percentage, and I'd want to see that as being quite large. As we mentioned before, when we looked at those differences throughout the rut phase in movement rates and bedding percentages, and we can see those huge differences, 200 yards per hour between the rut phases, that outside the rut and the peak rut. And when we've sat in the field in our stands and we've seen that change in activity, that's what we're looking for. We're looking for these larger numbers. And as the survey said, probably a difference of 50 yards per hour.
Yeah, 50 yards per hour or 30 minutes. And that, Natasha, that's a great point. You would want to see approximately equal and opposite changes in movement rates and time spent bedding. If you're seeing an increase, I mean, these are all so close to zero that I just view this as random variation in the data. But, you know, if you saw a significant increase in yards traveled per hour on a day of a certain rating, you would want to see a decrease in the amount of time spent bedded, ideally. You know, you could have a buck getting out of his bed at the same time and he's just moving a lot more once he gets up. But, you know, ideally, to really put stock in these results, like Natasha, I would want to see, you know, increase in yards per hour, decrease in the amount of time bedded. That would give me the most confidence that something was actually going on here.
What would give me confidence as well is the direction of the effect, as small and trivial as the effects we see are. For example, if we went from day rating of 2 to 3 to 4, it seems like we would see a consistent direction, meaning it's all positive, and then we would see the magnitude of the effect get greater.
Yep.
So we might go from a day rating of 2 of 1 yard per hour, day rating of 3 of 4 yards per hour, day rating of 4 of 10 yards per hour, even as tiny as that effect is. But we actually see a switch when we go from a day rating of 3, which is 95% full, to a day rating of 4, which is 99 or greater percent full. We see a complete switch in the direction of yards per hour.
Yeah.
We go from positive 4 to negative 0.3.
Yeah.
So my interpretation is that is random error.
That is a really, really good point. And if we've looked at so many different kinds of the moon in this analysis that I'm not even going to go into, and that's the pattern we want to see. If we see any difference, is that day rating of 1, 2, 3, and 4 changing? But this is just the moon phase, and we have looked at this before as a lab as well, and we didn't see a difference then. So we will move on to moon position, which is first of all looking at major windows. So in those 2-hour windows, looking at the change in Buck's usual behavior over the whole population, we see an increase of 3 yards per hour and a decrease in bedding percentage by 0.7. These are very small numbers. Yes, the direction is what, if we believed in this theory, if we thought major windows were having a huge effect, the direction is right. But those numbers are very, very small. And as we mentioned before, 3 yards per hour with our GPS errors on the collars is essentially 0.
Yeah, that's 3 steps in an hour.
And in our major windows, minor windows, we just did major, those 1 hour long windows, we don't even see the directional pattern we'd want to see, and the numbers are even smaller, 2 yards per hour, and an increase in bedding percentage.
Yeah. Yeah, so those do not correspond whatsoever in what you would expect, both in the direction and the magnitude of the difference.
Yeah, I think I would describe them as conclusively inconclusive. I mean, it's conclusive that there is no conclusive effect from the major and minor windows on the changes in behavior of individual bucks during the daytime.
And just yet another reminder, we began this with that, for those viewing, with that bar chart of showing the difference in the movement rate in the non-rut to the peak of the rut, contrasting those. 200 yards per hour versus 400 yards per hour, a delta or a difference there being 200 yards per hour equates to a meaningful, tangible difference that universally hunters see and say, yeah, there's a difference in buck behavior during that time. So we're going from a difference of 200 yards per hour now to, in a major window, of 3 and a minor window of 2. So again, my opinion, a trivial difference that is probably measurement error and does not really deviate from 0.
And it deviate. This is meaningful and trivial relative to the hunter's own input from the survey, which was 50 yards and what was it, 10% change in bedding?
Half hour. Half hour.
Mm-hmm. Yeah, it's around 4 or 5% in the daylight hours, but yeah. So this is our major and minor windows, which is to do with the moon's position. Previously, we just looked at the moon phase. So we're going to look at combinations of the two, which is really what the solar-lunar theory tells us. It tells us which days to hunt based on the moon's phase, which is the day ratings 1, 2, 3, or 4. And it also tells us what time of day to hunt, which is this major window or this minor window.
Yeah, so just kind of taking this back to our survey results real quick, we saw that 25% of hunters, of the hunters that believe there was an effect of the moon on buck movement, 25% of those believe that it was moon phase. And we looked at that with the day rating and saw that based on the solar-lunar theory, we saw virtually no effect of that. Minuscule changes in yards per hour and minuscule changes in time spent bedded. Now here we're looking at moon position, which was only 13% of moon theorists, but 13% still, I mean, that's not an insignificant proportion of hunters or number of hunters. And again, we see very, very small changes in both yards traveled per hour and percentage of time spent bedded during daylight hours.
So for this next page of results, if you're watching online, we're looking at major and minor windows and also those day ratings. I'm actually only going to display day ratings 1 and day ratings 4 just for visual purposes. And we'll talk through these, but we do also have the results for days rated 2 and 3 in between those.
Yeah, so keep in mind this combination between moon phase and moon position was by far the most common theory for how the moon influences buck movement. About 50% of hunters that believe in, the moon in some way, shape, or form, believe that it was this combination. Not either of the other things we talked about, the phase in isolation or the position in isolation, but the most hunters believe that it was this combination between phase and position.
Absolutely. And here's our results for major windows with different rated days. So again, we're only displaying day rating of 1, day rating of 4. Let's talk through these. Major windows, a day rating of 1 would see a increase of 1 yard per hour in movement rate and a decrease of 0.6% bedded, where 0.1% bedding is about 0.7 minutes, so a couple of minutes. Day ratings of 4, we saw an increase of 4 yards per hour in movement rate and a decrease of 0.9% bedding. Now, looking at these and trying to remember what the day ratings are, we'd expect more activity in day rating of 4, less activity in day rating of 1. And these are very small numbers again, but even if they weren't, the directions aren't quite right for a day rating of 1. We'd expect there to be less activity on a day rating of 1, more activity on a day rating of 4. And although we're not showing them, day ratings of 2 and 3 are pretty similar numbers with mixed up directions again. So nothing interesting there, although 4 yards per hour and 0.9% change in bedding might seem large. That 0.9% in bedding is only like 6.5 minutes, I think.
Yeah, and keep in mind, these major windows are moon overhead or underfoot, plus or minus 1 hour, right? So these are 2-hour windows. So a change in 4 yards per hour means that over the course of a major feeding window, a buck is moving 8 more yards. I mean, that's well within the measurement error of our GPS collars. And, 8 yards? Like, how many hunters out there have an 8-yard pin on their bow? It's less. It's half the first pin you're going to have on your bow, which is nothing.
Yeah, and it's worth mentioning here because I'm not sure we did when we talked about major and minor windows in the previous results, is that we're comparing these major windows. So, for example, if this major window, which is 2 hours long, was from 2 p.m. until 4 p.m., we're comparing this window to the buck's usual movements from 2 p.m. till 4 p.m. with the 2 weeks surrounding this day. So we are looking at comparing what they'd usually move at that time of day. So this is accounting for the time of day, it's accounting for the individual buck, it's accounting for the rut phase.
And this is just me, but I put so much more weight. This just may be the way my brain works. Maybe I can just relate to this better. I put a lot more weight in the yards per hour than the bedding. And so I think about, someone could say, like Luke alluded to a moment ago, okay, so there's a 0.9% change in bedding, which that's going to be about 6 minutes. And so someone could say, well, 6 minutes for a bow hunter, 100 yards from a bed or in between bedding and food, 6 minutes can mean all the difference in the world of getting a shot or not. And I think that's true. But the bedding, again, is just that we were able to detect that the buck had essentially stood up and moved some critical distance, and it was not detected that it was in his bed or not. So in other words, it could have stood up and moved a little bit, and so it would not be detected in his bed. But the yards per hour, to me, is more tangible and meaningful, that the buck is on his feet and covering ground, and it's introducing an opportunity for a shot. And so then when I relate that to, okay, yards per hour is most meaningful, and I go back to, that's 4 steps. That's, for me, over an hour, 4 steps. I'm just not that impressed with the response.
Yeah, I think I could see these results being interpreted in one of 3 ways. And I guess they're not mutually exclusive. Way 1 is the way that I personally interpret these results, which is that these numbers are minuscule relative to what a buck is moving during the peak rut. His just, total yards per hour on an average day. I mean, 4 yards per hour, is nothing. It's no change. And that's one way I think you can interpret it. The other way you can interpret it, and I see this side of things, and I think there's an argument to be made here, is that shooting a mature buck, or even having an encounter with a mature buck, or even seeing a mature buck, these are low odds games that we're playing here. These are low odds opportunities that do not come around often. And when they do come around, any small change you get in your percentage of success can be meaningful. So because we're playing very low odds games, a little change could be meaningful. So I can see that argument. The other argument, from more of a statistical or mathematical perspective, is that these numbers we're talking about here are oscillating right around zero. They're up, down, directions are changing depending on what we're looking at, and it really, to me, like we've said before, this seems like random error.
And we can actually see a little bit more of that, especially with this oscillation around zero, direction being not really making sense in the minor windows, where we see day rating as 1, 0.5 yards per hour, which is essentially zero change, and a decrease in bedding. So it looks like they're bedding less, but they're moving less as well. It doesn't make sense, which again shows a likely measurement error. Days rating of 4, we've got an increase of 10 yards per hour, which is the biggest we've seen so far, but also an increase in bedding of 1%. So they're bedding 7 minutes more, but moving 10 yards per hour more. Again, they're not making that much sense with each other. Of course, that could happen, but really we'd expect to see that increase in movement rate, that decrease in bedding, to really see activity. And although 10 yards per hour is the biggest number we've seen so far, it's not even reaching that 50 yards per hour from our survey. And it's certainly not anything near that change in rut phase where we see an increase of 200 yards per hour.
Yeah, that's a great point, Natasha. Keep in mind, we asked y'all what you think a meaningful change would be, and the most meaningful change we've seen so far is 20% of what you thought a meaningful change would be. It's 1/5. We're not even to half of what you thought a meaningful change would be. And I'm not saying that's representative of all hunters. There are probably some hunters out there that believe a 10 yards per hour change is meaningful. But that is not what the vast majority of hunters believe. The other thing I'll say here is that I have heard, and with some good explanations for the differences between theories on major and minor windows. Some people believe that major and minor windows you're just as good hunting a major window as a minor window. Some believe that they'd rather just discount the minor windows and only hunt the major because they're more of a believer in the gravitational pull. Some are more believers in the minor windows than the major windows, and the theory that I've heard behind that is that the minor windows is all about the change from there not being a moon on the horizon to there being a moon on the horizon. It's like the really strong effect that we see with dawn and dusk. The sun is not there, and then within an hour, everything's bright. And it's that really acute change in light on the horizon and light on the landscape that's really getting deer on their feet. And obviously, I don't think there probably are some, but there are very few hunters out there, if any, that believe that the moon's effect is greater than the sun's. But I think that's kind of where the theory comes in with minor windows, is that it's about the change in there not being a moon in the sky to there being a moon in the sky.
And I'll ramble a little bit on a slightly different perspective. Back to the hunters that are going to say, but 10 yards does matter. Now there might be a circumstance where you're on your stand and a buck moving 10 yards sooner would get them into your shooting window before it's too dark to shoot. So yeah, there might be a case in an extreme situation for an individual hunter with an individual deer moving in that 10 yards is meaningful. But what we're talking about here is, on average, should you plan your hunt around a potential 10-yard change? It's still minuscule. You shouldn't plan your hunts around this. But even though, yes, if you're ready, and you're waiting for a deer to come into your shooting spot, 10 yards might be meaningful.
So one thing we have looked at is the huge difference in rut phase on these descriptions of activity, the movement rate and the bedding percentage. But what we've touched upon, but not really looked at the numbers for, is dawn and dusk. We know the deer are moving more at dawn and dusk. So looking at some numbers to do with that, our yards per hour and our bedding percentage, and again, this is averaged over the whole population, over the whole season, our bucks are moving 293 yards per hour. And this is actually within an hour of dawn and dusk. So an hour either side of dawn and dusk is what we've got here. And they're bedded down for about 25% of those hours. So that's much less than in general, where they're bedded down about 34%. So we already know there's more activity in terms of our measurements at dawn and dusk, which is what we've seen in previous research too.
So I guess perspective there on the previous slide, where we found the greatest yards per hour effect was a 10-yard difference. When we look at these results here, it's saying rather than an average response of 293 yards per hour, it would be 303. That's the magnitude of difference. So you're going from 293 yards per hour, and then on that special day rating, it would be 303. Am I interpreting that correctly?
Yeah.
I might argue against that being totally appropriate, because this is the total yards moved, not the change in yards moved.
Yeah, I mean, that's a good point. When we look at all these changes, the reason we're looking at the changes is because they take into account the individual personalities, the rut phase, etc., the time of day. And this does take into account the time of day in a sense, because we're just looking at dawn and dusk. But it doesn't take into account all of those things. So this is just a general idea, a general showing that we have more increased, we have a larger movement rate, and we have less time bedded.
Yeah, and that's the valid point.
Yeah.
Okay, Steve, I'll give you that.
I'm going to jump straight into minor and major windows combined with our day ratings. We've looked at all these things separately too, but we'd be here all day if we start separating everything again. We're just jumping straight into that. And I've not shown the results there yet, but I've shown the structure of our results, which is our major windows and our minor windows on different day ratings. Now, major windows on days ratings of 2, 3, and 4 are not shown there, or a day rating of 4 at least is not shown there. And there's a reason for that. That's because the moon being full, for example, let's just think about full moons. So full moons are days rating of 4. And slightly less full moons, days rated as 2 and 3. They don't occur at dawn and dusk in these major windows. Major windows are when the moon is overhead and underfoot. Days rating of 4 is when the moon is full or new, but let's just say full. And we don't see a full moon when the moon is directly above us and it is dawn and dusk. To do with how the sun is shining and how we're looking at the moon and how the sun is shining, that angle, it just doesn't work. So there are not major windows at the same time as dawn and dusk on days rated 2, 3, and 4. So that's why we're not showing that. And that gives another interesting statistic. And that is that 70% of minor windows, and this is in our data, which is in 2017 and 18, but it's around the same figure when we look at different years. 70% of minor windows that happen within an hour of dawn and dusk are on days rated as 3 and 4. So what that means is 70%, a large proportion of our minor windows, actually happen at dawn and dusk when we know the deer are moving more. Are on these days rated as 3 and 4. So the moon is either 95% full or more, or 95% new or more. So we expect more movement on these days, on these minor windows, compared to other times, just because they're so close to dawn and dusk.
Yeah, I think it's worth spending a little more time here. A minute ago, Doc, or gosh, probably an hour ago at this point, Doc was talking about, or at least implicitly talking about confirmation bias and going out on a day because you think it's going to be good, and then seeing deer and being like, "Oh, I saw deer because it was good." Well, that's just the day that you were out, and then we tend to ignore just the way the human brain works. Our brain is designed to find patterns in things. The way our brain works is we often ignore observations that contradict the patterns that we believe exist. So, with this, 70% of minor windows happen within an hour of either dawn or dusk on days rated as 3 or 4. I think this is a great example of that. We are more likely to see deer on the highest rated days during those minor windows, but it's not because of the moon. It's not because of the moon necessarily. It's because of it's just the way the Earth orbits the sun and when dawn and dusk are, and the way the Earth orbits the moon. It's just the mathematical probability that 70% of those minor windows are going to occur at dawn and dusk on days 3 and 4, the higher day ratings. So it's not necessarily because of a moon effect. It's just the random. It's not random because of astronomy and things, but it's just the chance of the moon and sun being where they are, if that makes any sense. I probably made that more confusing than it originally was.
Yeah, and this touches on something we aren't really talking about here, but these solar-lunar tables, or at least the ones I've been looking at, they have these heightened ratings. They're like they call them better days, which is when we have these minor windows coinciding with dawn and dusk. And that's a heck of a lot of them. But also it means that like those better days are just because they are close to dawn and dusk.
So here with these results you're showing, Natasha, the major window here would be a red moon scenario, correct? So it's dawn and dusk, and simultaneous you've got moon overhead or underfoot.
Yes, yeah, ignoring the day rating.
Right.
So the red moon theory, as far as I'm aware, does not take into account moon phase. So ignoring the day ratings, which we have to do for major windows at dawn and dusk anyway, it's only a day rating of 1. Then yes, this is where the red moon theory comes in, is these major windows at this time. And so when we show these results, we're comparing these increases or decreases at other days at dawn and dusk. So these whole results that we're going to show, it's always at dawn and dusk, and we're comparing to that book's usual movements at dawn and dusk, and seeing whether or not there's a change in the major and minor windows, and in the case of the minor windows, whether there's a change in the day ratings too, compared to their usual movements at dawn and dusk. So we know they're going to move more at dawn and dusk, and if we compared it to every time of day, we'd see an increase anyway because it's dawn and dusk. So we compare to those usual movements, which is basically saying, well, is it better for me to go out in a major window at dawn and dusk or just any day at dawn and dusk? So I can show those results now. Same movement descriptions of activity as before. We've got our movement rates, yards per hour, and we've got our bedding percentages. And in these major windows, we see a slight decrease, which is essentially 0.4 yards per hour, and we see a decrease in bedding percentage, 0.8%, which is just very low. And also don't really agree with each other. And in those minor windows, a day rating of 1 is a decrease of 10 yards per hour in movement rate and an increase in 2% of bedding percentage. And this is actually what the solar-lunar theories say, although these numbers are far too small. This is the right directionality, that there's a decrease in movement and an increase in bedding on day ratings of 1 because they're not supposed to be as good, but this is still in the minor window. And then day rating of 4 in a minor window, which is supposed to be one of the best times, we see an increase in movement of 3 yards per hour, which is kind of essentially 0, and absolutely no change. It was like a 0.02 or something, so 0% increase in bedding, and that could have been a decrease, but it was something like 0.02%.
Yeah, so we've introduced a new variable here, and that's dawn and dusk, relative to what we were talking about before, which was just major and minor and day ratings. However, these results are almost the opposite of what we saw. If we're just talking about minor windows, it's almost the opposite of what we saw when we were just considering moon phase and moon position independent of dawn and dusk. Remember, a few slides ago, we were talking about during a minor window on a day rating of 4, we saw a 10 yard per hour increase. And whether or not that's a significant change is up to you to decide. But now we see only a 3 yard per hour increase on a day rating of 4 in a minor window. And so it's just like we're not getting, no matter where you look in these results, we're not getting consistent effects in any direction for any of our response variables. And I think that's the biggest take home for me thus far.
Completely agree. So I just keep coming back to we're essentially finding no result or just the slightest deviation from normal, which could just be measurement error. But because the direction of the effect keeps switching without any consistency, I think it's random.
Yeah, and I would agree as well. And even 10, we see this number again, 10. But as we said in previous results, it's not really enough of a change for us to say that these minor windows or these major windows at dawn and dusk are better than any other day at dawn and dusk.
Yeah, and for people at home listening, we would not, as researchers, if there was no effect, if there was zero effect of moon on movement rates or bedding percentage, we would not expect to see 0 yards per hour and 0% change. We would expect to see some random error in the results, and I would expect it to look very much like it does here. Now, if we had every deer collared in North America, or every buck collared in North America, and we had locations every 1 minute, and GPS accuracy was 100%, like they were spot on to where the buck actually was, I would expect these numbers to get closer and closer and closer to 0 as our precision, our estimation precision increased. But this is pretty much exactly what I would expect with our data if there was no effect.
Thanks. Yeah, that's a really good point. This is exactly what we expect instead of zeros. And here this might be a point that might be not worth mentioning, but we use the mean here, which is a measure of average. It's what most people use if they say average. It's the mean. We also did this when we looked at medians, which is a slightly different way of measuring the average, but takes into account just lots of different ways that the data might present itself. And we find the same results. We find exactly the same results. And that's a really important point, that we're also not just looking at the mean, we're also not just looking at the median. We did this with some statistical models too. But what we're displaying here is the mean. It's that kind of average that lots and lots of people use. And that's why we see these small, tiny errors, because we're never going to see a 0, or it's unlikely we'll see a 0. But that's a really good point, Luke.
Yeah, and I think, Natasha, that's a good point. So I think that was worth mentioning, because the median, generally speaking, is going to be less sensitive to outliers in the data. The mean is, generally speaking, going to be more sensitive to outliers in the data. So if we have one really extreme buck that is, going crazy on full moon days, we would expect that to show up more in the data if we use the mean. But because we're using the mean here and still not seeing an effect, we'd expect even less of an effect if we were showing you the median results, if there was something going on with just a few bucks. So I think that's an important point for those listening who, appreciate the difference between a mean and a median and a mode, etc.
So that's our dawn and dusk results, and we'll talk a little bit about different kinds of days later too. But we're going to go back now to thinking about those bedding down times. So what we've done so far is we've talked about book activity in terms of the book's movement rate per hour, and also in terms of their percentage bedded down of daylight hours. Now, one thing we also put into the survey that we mentioned before is how does that time change when the books leave their bed or bed down at the start of the day? So before we go into that, just a little bit more about our data. which is when a buck's bedding down at all in the daylight hours. So this is the legal shooting hours, which is 30 minutes before sunrise, 30 minutes after sunset. And I'm showing here, if you're watching online, a sort of a timeline of the day, which is if the bucks were bedded down once. Bucks do not always bed down once in the middle of the day, but sometimes they do. In fact, about 1/8 of our data, bucks are bedding down just once in the daytime, and that is way more likely in peak rut. But when they do bed down once in the daytime, it's generally about 5 hours after legal shooting begins and about 5 hours before legal shooting ends. But more often than not, they're bedding down multiple times in the day. And that is generally the first bedding down time after sunrise is about 3 hours after legal shooting begins. And again, about 3 hours before legal shooting ends, just to get a general idea of when that's happening.
Yeah, so this specifically doesn't have you needed to quantify this stuff in order to answer the next question, but this isn't directly what we're talking about with the moon here. But this is fascinating in and of itself, I think. That one, you said 12, you said 1/8, which is roughly, it's 12.5%. So 12.5% of bucks. I'm not sure if I'm interpreting
Not
this
quite
exactly
of bucks
right.
of our data. So if you separated all our data into days and bucks, about 12% of the time they're bedding down once.
Okay, and then you said the majority is multiple beds, and what was the most common there? 2, 3 beds throughout the day? Do you remember?
2 or 3. It depends on rut phase as well, and we will release those figures over the next few months because we have them and we're in the process of publishing them.
Yeah. So regardless of whether it's one bed, which is only 12% of our data, or whether it's the majority of our data, which is multiple beds, that first bed isn't taking place until about 3 hours after legal shooting begins. So sunrise, let's say it's at 7 o'clock, so legal shooting was at 6:30. So 9:30 he's not going to bed down until, on average, 9:30 ish in the morning if it's a multiple bed, a buck with multiple bed, and if it's one bed, it's not going to be until closer to noon, which is pretty incredible.
Yeah, and this really is an average, and we have a whole lot of work coming out on the differences in this average and where we see differences, and it's not something we're going to go into now. This is just a real average over all the days, over all the bucks. So the point here I'm making is that we're only caring in this particular podcast, in this particular analysis of these bedding down for the first time in the morning after legal shooting begins, which is on average 3 hours after, and leaving the bed for the last time before legal shooting ends, which again is about a 3-hour period. We're looking at the changes there. Again, there's multiple beds in the middle of the day. There's multiple beds maybe at night too, but we're not looking at that here. We're just looking at those 2 times and the differences, which if you're watching online, we can see an example of here with this timeline. So some results. We do see something that might be slightly interesting here. Which, have you got your hand up there, Luke?
Oh, no.
I like the
You're just having a
qualifier there,
giggle.
though. It might be of slight interest.
Yeah.
Well, I mean, it's still below our threshold. However, it's the biggest number we've seen so far. So we've got major windows here. So what this means is, this is whenever they're bedded down or leaving their bed for that first bedding down time in the morning, for that last leaving bedtime in the afternoon. And it also occurs in a major window, or alternatively, it also occurs in a minor window. That's what we're looking at on this slide. So if this occurs in a major window, this bedding down time in the morning, on average, it's about 0.7 minutes later. So that's essentially 0. Doesn't make a change. And 1.5 minutes later, leaving the bed in the afternoon. So these are kind of like a 0 again. Really, the direction doesn't make that much sense with it being later or earlier. But in major windows, we don't really see a change. In minor windows, on average, we find that bucks are bedded down for 18 minutes later in the morning. So they choose to bed down 18 minutes later if it's within a minor window, or leave the bed 6 minutes earlier if that's within a minor window in the afternoon. So this is a slightly larger number than we've seen, 18 minutes later. It's not the same thing as our bedded percentage, but it relates to it. But whether or not this hits the threshold, no, it doesn't. Hunters suggested to us that it would be 30 minutes or more as a change for this to be seen in when we're sat in the stands. But it's still a slightly larger number.
Yeah, and so I'm thinking through this. If we were going to come up with a scenario where we would see the strongest effect of moon position and or phase on when a buck is either bedding down or leaving his bed, I think we would probably see it when it was within a major or minor window. However, I think that most hunters, and we didn't get at this specifically in the survey, but I think that most hunters are interpreting major and minor windows when they're thinking about it in the context of when a buck is bedding or leaving his bed or whatever, in that the bedding event does not have to be within the major or minor window. It's more so on, well, no, it would have to be, because there's a major and a minor window every day of the year. So that doesn't even make sense. Forget everything I just said.
We did also look at not just when these waking up or leaving the bed and bedding down times occurred within these windows. We looked at if there was a minor window that occurred in the morning, does it affect whether or not they bed down, what the time that they bed down? And we didn't see any results on that. This was a slightly different thing. So the fact that we didn't see any results when the minor window was just at some point in the morning, nothing there.
I guess my comment is, Steve, if you're looking for an effect, there's your effect. There's your, instead of a buck bedding down at 9 a.m., it's going to bed down at 9:18. That's the strongest effect out of all of these that we found.
Yeah, all of these effects we've been talking about are, you could come up with an instance where it might happen, but on average, don't make your plans around something you read in the calendar.
And on that point, I was just going to again mention that we're taking these locations every 15 minutes. And Luke and I spent a huge amount of time designing an algorithm to understand when the bucks are bedding down and when they're not bedded down. Yeah. And there's an error in both of those things. So this 18 minutes, to me, I'd like to see probably an hour, to be honest, an hour difference. When we look at the percentage that they're bedded down in peak rut compared to no rut, and that 15% difference, and that being way over an hour, that's what I'd like to see. It's 45 minutes to an hour probably difference. And so at this point, these are our main points of the solar lunar theories, the red moon theories, look at. But we also wanted to think about some things we'd heard from the hunting community on the differences within all of these. So one thing we looked at was, what about the full moon having more light? So you guys can help me out a bit here with reminding me of all the differences, but one of them being, if the full moon has more light, are they moving more at night because they can see more and then moving less in the daytime? If the full moon has more light, does it mean they're bedding less in the nighttime? There's lots of different ways that we could look at this. So the first thing is just looking at the daytime activity, which is what we've cared about in all of these results, which is, are they moving more or less in the daytime, given the fact it's a new moon or a full moon? Because previously we've had these days rated, these day ratings, 1, 2, 3, and 4. 4 meaning the moon is either full or it's full or new. So we didn't separate those instances out, but lots of people have asked about that. So separating the moon into full and new moons actually doesn't show any effect on deer activity in the daytime. And when I say any effect, here's our numbers. Full moon and new moon, 4 yards per hour decrease in movement on a full moon, 3 yards per hour decrease on a new moon, and very slight decreases in the bedding percentage, which again are essentially 0. Now, I've only shown these as a full moon and new moon, but we have also looked at minor windows, major windows, day ratings too, which will all be in our publication we'll release in the next few months. We've looked at all those instances, separating out the full moon and the new moon, and we haven't seen anything larger than this. It's been these like essentially 0 measurements again.
Yeah, so I think what this indirectly gets at is this question of luminosity, and this is another whether it's a theory in conjunction with the other ones we've been talking about, or an independent theory about how the moon might influence buck movement. It comes down to luminosity, which is essentially how much light the moon is emitting and lighting up the landscape where a buck is bedding or walking or feeding or whatever. And so So luminosity could be influenced by many things. One of them could be, what is the phase of the moon? Is it a full moon where it'd be very bright, or is it a new moon where there's very, very little, if any, light bouncing off the moon from the sun to the earth? When I say the moon's obviously not emitting light as like it's got its own light source, but how much it's reflecting. So the phase of the moon is one way to get at luminosity, or one way to think about how much light the moon might be reflecting. But the other way is cloud cover. And cloud cover is extremely difficult to look at for a study like this unless we've got a weather station on site that is measuring luminosity, which we did not have for this study. So that's, I say that kind of just as a, whatever, to say that we weren't able to look at luminosity specifically relative to cloud cover with this analysis. However, if there was an effect of luminosity, I would expect to see it manifest in full moon versus new moon, because a full moon, on average, accounting for all the data we have, all the different days, on average, there's going to be more light reflected by a full moon than there is by a new moon, regardless of the cloud cover. So, I guess to sum all that up, we can't directly address the luminosity question because we don't have really high resolution cloud cover data for all of these days. However, if there was something going on there, I would expect to see differences in the full moon versus new moon yards per hour and or time spent bedded.
Yeah, so to tag on to that, cloud cover is going to influence the full moon effect. However, with the amount of data that we had so many instances where there was 98% full, 99% full, 100% full, etc. So we had so many days where we had a full moon that over 2 years of the study, if there was a consistent signal or any signal at all with the luminosity effect, we still would have picked it up. The effect would have been dampened somewhat because some of those times, potentially, when you had a full moon, there could have been cloud cover obscuring the amount of light, but there would still have been enough instances to where if there were a consistent signal of a full moon, we would have detected a difference. And we're seeing a difference of 1 yard per hour, 4 versus 3.
Yeah, and as we've said before, this is very likely to just be error. I mean, the directions don't even make that sense. And one other point is that we did look at deer activity at night as well. Although we'd expect that if they were moving more at night, we'd see that effect in the daytime. For example, if the full moon meant more activity at night, we may see less activity in the 2 days surrounding that. However, we decided to look at night too. And we also looked at full and new and also the different day ratings and also minor and major. And we found no effect on the deer activity when the moon was full or new at night.
Yeah, and again, I think this point's worth stressing. When we were talking about some of potential mechanisms for effect of the moon on buck movement, one of the ones that we commonly hear that I mentioned was that on a full moon at night, bucks are on their feet more. So on the day following that, or the days surrounding it, bucks are on their feet less during daylight hours. And so the vast majority of these analyses that Natasha did are focused on hunting hours. However, we want to just for sake of being very thorough, Natasha also looked at the nighttime potential effects and again saw nothing.
So in addition to looking at the full moon and the new moon separately, we also thought about differences in the position. For example, the moon is closest to Earth every, say, 25-hour cycle when it's overhead. But we also have a point in the month where it's closest to the Earth over all of those points, which is called the perigee moon. And we also have an apogee moon where it's the furthest away. So we also looked at when these times occurred on top of the fact that the moon was overhead or underfoot and all the different ways of looking at the moon position. And we also found no effect. So I'm not showing all the figures here. We have them in the publication. We have all the different ways of looking at this. But it was a similar thing again. Similar kinds of numbers for movement rate, similar kind of numbers for bedding percentages. I just wanted to get that out there that we did look at this as well additionally.
And so, Natasha, this would be where we were thinking about if the moon's gravitational pull had any type of influence. In previous analyses, you were looking at that on a daily scale, rising, overhead, underfoot, etc. This is a different phenomenon based on orbit, and it is on a monthly scale. So
yes, about every 28 days.
A number of days where the moon is closest to the Earth and hence greater gravitational pull, and then days where it is furthest away. So in this, you were looking at it relative to days rather than time of day. It would just be a perigee group of days and an apogee group of days.
Yeah, I think we looked at maybe the couple of days surrounding it. So 2 days either side. It's almost a 4-day period. Mm-hmm. We looked at those periods and we looked at the moon being overhead and whether or not that had an effect on the movement.
And so, Natasha, did you also, when you were doing this, did you also look at all of the different combinations of previous variables? Like,
yes.
Yeah. So my point is, and I guess the point of this whole thing is that we have made, just as an example, we've made social media posts before showing buck movement rates over the course of the entire hunting season, and on the same graph we've plotted the cycle of the moon. So, full moon at the top, and as it's cycling down, new moon. And people are like, but you didn't account for all of the things we've talked about. Find a variable that we didn't account for. And I don't say that to be confrontational in any way, but I say it because I think this is as exhaustive as you're going to get.
We want input and comments, and if you want to start a debate among your hunting friends, send them a link to it and say, hey, watch this or listen to this, and let's have a discussion around the campfire at the hunting camp.
Yeah. And I mean, we certainly welcome feedback, and we welcome questions, and we welcome when people tell us that, well, yeah, but you didn't account for this or you didn't account for that. Because to be honest, like, a lot of this analysis is because of the feedback we've gotten from hunters saying, yeah, but. So we try to integrate all of those yeah, buts into this. However, I think it's important to evaluate the data and the results as objectively as possible. We got over 1 million GPS points, over 60 bucks. Most of these bucks are very mature, 5, 6, 7 years old. This is as convinced as I will be until more convincing data comes out.
And I think on that point, there is, I'm sure, some very experienced hunters out there have spent many hours and years in stands. We have data here that doesn't have that hunting pressure associated with it. Well, in some cases it may, but this is different to what you're observing in the stands. This is measured deer activity, regardless of hunting pressure and accounting for times of day as well. why don't we move on from perigee and apogee moons? This is just movement rate per hour. I've not got bedding percentage here. And this is similar to the bar chart we showed right at the start. And if you're listening right at the start, we showed a bar chart that showed the movement rate and how it changes throughout the rut. So here we're showing again a bar chart and how movement rate yards per hour changes throughout the rut. But also we've split up each rut phase into all kinds of data, just minor windows, just major windows, and also just dawn and dusk. So on top of us splitting up by rut phase, we've also split up by minor and major windows and also dawn and dusk. Just to show these effects of the rut still being so clear, and in some cases dawn and dusk still being way more or equal to minor and major windows in this sense. And we have this graph as well for bedding percentage, but we're not showing it just because it shows a similar thing. But just to make clear again that we do see differences in deer activity with our measurements, but these are based around the rut and also dawn and dusk.
So yeah, my take home here is at where we began. We're not seeing any influence of the moon that would supersede, for example, the influence of the rut. And, now that's over a long time period. That's over a season. But then even notice that in minor and major windows, there is either no effect relative to dawn and dusk, or the values are less than during dawn and dusk. So again, it just keeps bringing this home that if there is any effect whatsoever, my perspective is it's random. And if there is an effect, it is so minuscule compared to the things that we already know. And some of the things I've always said for years, the things that we know are that deer are moving more sun up and sun down. And generally we see a population response during phases of the rut. If there was any effect of the moon at all, it is so small compared to those tangible differences that we see with rut phase and sun up and sundown.
And I will press again that this is not taking into account those individual books and things like that. But when we have done a much more thorough analysis and shown this graph where we do have the changes and the increases, and we're still in agreement that this is the case. So although we're not showing all of those graphs right now, we will have them in our publications, but we still see the same pattern, that we just don't see a measurable effect. Our conclusion, our agreement, is that the phase and the position of the moon does not affect our Mississippi books. And as Luke said, he doesn't see a reason for why this doesn't extend to other populations throughout the US. But we do see the books are more active in peak rut. Of course, we do see the books are more active using our measurements at dawn and dusk. And one last point that we haven't mentioned, and a bit of a teaser for forthcoming publications and podcasts, is that books are more active in some weather conditions, which is not a topic for today.
Dropping a little teaser there, Natasha.
I've been humbled adequately. Thank you, Natasha.
Hopefully it's been revealed now how complex this was, and all the different things that Natasha had to disentangle, all the different correlations that are possible, and isolating all of these effects and doing it by a buck's pattern deviating from his normal 2-week pattern, etc. It took a tremendous amount of thought, expertise, and coding to be able to do that. So, Natasha, we are very, very grateful. Thank you for your time and hopefully a very enlightening analysis on the effects or not of the moon on buck behavior.
Thank you. No, it's very enjoyable. And it's even more enjoyable when we've got a whole load of other variables coming out in the next few months.
That's right. More to come. More to come. All right. Thanks, everyone. And we'll see you next time.
We thank the Patrick F. Taylor Foundation and the St. John and Dudley Hutchinson families for their endowed financial support of our efforts.
We also thank our employers, the Mississippi State University Extension Service and the Forest and Wildlife Research Center. If you have questions or suggestions, please log on to msudeerlab.com and click on the Deer University tab.